Hi everyone. So today's topic we're going to be doing a differentiation of logarithmic functions. So basically your ln x squared. Here are the examples that we're going to be doing that are displayed on the screen. These are the 5 examples that we're going to be doing. So without any waste of time, let's just jump to the first example. So the first example, let's find dy over dx of ln x. So we're going to use this formula. Here's the formula that we're gonna use. It's in the formula sheet. You'll see the formula that is equivalent to this one. But then in your formula sheet, this part is not there. This part is not there. So I'll just explain this part here. So this x that you see, they normally say let u equals to your f of x, which is this x here. So basically what they normally do, they say let this x be u. That's what they normally say. So but then in my case, I'm not gonna say let this be u or let this be what. No, I'll just show you the quickest way of doing it, the quickest method of doing this. So I'll just erase this u. So basically always you take your function of x, then you're gonna apply this formula right here, the formula that is on the right hand side, top right hand side. So you're gonna say dy over dx equals to, and then you're gonna apply the formula. They're saying when you differentiate ln of x, you're gonna get 1 over x multiplied by d over dx. Then you're gonna take this, you're gonna take whatever you have there and put it here. Okay, then here we have got x. So remember from the previous videos that I uploaded, the basics of differentiation. So this means you are differentiating this part here. It means you are differentiating x. So the differentiation of x, remember that formula, nx to the power n minus 1. So when we differentiate x, remember x is raised to the power 1. X is raised to the power 1. So you're gonna say your n is 1, which is this one here. It's your 1. Then x to the power of 1 minus 1. So you're gonna get x to the power of 0. So remember, anything to the power of 0, you're gonna get a 1. Okay, so meaning this one is your d over dx is x. So your dy over dx it's gonna be 1 over x. This is your final answer. Okay, so the next example, on the next example, you're going to apply the same method that you applied. Remember on the last example, this was your x. So you're going to apply the same method. Remember, whatever that is in the bracket, it's your x. They normally say let it be u. Okay, so in my case, I'm not going to let it be u. You just take this x. Let me just highlight it. You just take this whole thing as your x, as a function of x. This is a function of x, or f of x. So you're gonna apply the same formula. You're gonna say it's dy over dx. It's dy over dx equals to, then you apply that formula, the formula that is on your top right hand side. Then you're gonna say 1 over, okay, your x, your f of x in this case is what? It's 4. It's 4x squared plus 3x. Okay, multiply by your d over dx, which is 4x squared plus 3x. Okay, so your d over dx will be, you're gonna have to differentiate this. You're gonna have to differentiate 4x squared and 3x. So to differentiate 4x, you're gonna get 4 into, you're gonna apply that formula, the one that we just applied on the previous example. So you're gonna say your n is 2x to the power of 2 minus 1 plus 3x. Okay, sorry, it's 3x to the power of 1 minus 1 multiply by 1, because this thing your n was 1 in this case. So your d over dx will be 8x plus 3, because you're gonna get a 0 for this one. So for this one you're gonna get a 0. This one will minus, then this x will be raised to the power of 0, then x to the power 0, you know it's 1, so there's 1 here, so that's why I didn't write it. So your d over dx, you're gonna get 8x plus 3. So okay, let's go back to the initial equation. So you're just gonna take this and plug it here. So to plug this, it's easy. Let me just open a new window. I'm just gonna copy whatever that I wrote here to the new window due to space. So I'll show you guys how to do this thing. So I'll just open a new window and erase everything that is there. Okay, so I'll just copy the previous example. I'll just copy this and paste it on the next example, on the next page, sorry, on the next page. So I'm just gonna paste it here. Okay, so we're gonna take this, we're gonna take whatever we have and paste it this side. So when we paste it here, you're gonna plug it into your original formula, to this formula, the formula that we had. So to find your dy over dx will be equals to 1 over, remember we got 1 over 4x squared plus 3x, okay, multiply by your d over dx, which is this one here, so you're gonna write it here. It's gonna be, just open the bracket, 8x plus 3. This should be your answer. This is your final answer. Let's just do a recap. So we found this 1 over 4x squared plus 3x, so we had to find d over dx of 4x squared plus 3x. So we did find that, which was 8x plus 3. So here's your final answer. This is your final answer, this one right here. This is your final answer. So the next example, we're just gonna apply whatever we applied on the previous one. Remember what I said, this is your f of x, this is your f of x. This is like the one that you're gonna plug in here in this formula. So for this one, we're gonna say your dy over dx. Just use the formula sheet for this to solve such equations. Use the formula sheet, just add this part on your formula sheet. Just remember always this part, it's easier that way. So you're gonna have 1 over whatever that you have, which is 3 over x squared, okay, then multiply by your d over dx of 3 over x squared. Guys, remember this d over dx, remember it can be written as, to make it easier, it can be written as 3x to the power of minus 2. We put it in this format so that you can apply this formula to the power n minus 1. Okay, so to solve this, you're gonna get a minus 2 into 3, which this minus 2 is your n, x to the power of minus 2 minus 1. So you're gonna get minus 6 x to the power of minus 3. This is the answer that you're gonna get for your d over dx. This is the answer that you're gonna get. So you go back to your original equation. You're gonna say d over dx equals to, equals to 1 over 3 over x squared, okay, multiply by open bracket negative 6x to the power of minus 3. This is your final answer. This is your final answer. So always just remember to change the fraction to a standard form. Just change the fraction to a standard form so that it can be easier for you to solve it. That's the hint. Just note that. Okay, so we're gonna move to the next example. So the next example, we have got a constant here. We've got a constant of 3. Just apply the same method. Remember, this is your f of x, your function of x. But in my case, I said it's this x. Okay, so you're just gonna apply the formula as well. Dy over dx equals to, you keep 3 as it is, it's a constant, you don't touch it. Okay, and then you're gonna say 1 over whatever you have, which is x squared, multiply by, okay, let me just close the bracket, over d over dx into x squared. Okay, so we're gonna find our d over dx of x squared. So remember, derivative of x squared, you're gonna get a 2x. Applying this method, same method. So you're gonna go back to your original equation, dy over dx equals to 3 into 1 over x squared multiplied by 2x. So you can simply say your final answer is 6x. So you're gonna multiply this 2x with 3 because they're outside the brackets. So into 1 over x squared. Remember, you can simplify this further. Remember, dividing the powers of the same base, this can be written as 6x over x squared. Then you've got 1 here for this 6x is raised to the power 1. So remember, dividing the powers of the same base, what do you do? Using exponential rule, you subtract the exponents. So it's gonna be your answer is gonna be 6 over x for this one. It's gonna be 6 over x because you're gonna say 6x to the power 1 minus 2. So here you're gonna get a minus 2 here when you put it in a standard form. When you put it in a standard form, you're gonna get a negative 2, which is, this is your exponential rule. So to do a recap, I said you keep 3 as a constant, and then you say open bracket 1 over x squared, then multiply by d over dx squared. Okay, then you find the first derivative of x squared, then you're gonna get 2x. Then after getting that 2x, you multiply it with the original equation, then you're gonna get 6x over x squared, and then from there you divide 6x over x squared, then you're gonna get 6 over x, because when you divide the powers of the same base, you subtract the exponent. That's exponential rule. So let's move to the next example. So the next example is it's a combination. Basically, we have got a trigonometric function and we also have got a logarithmic function. So for trigonometric function, you just go to your formula sheet. To solve for trigonometric functions, you go to your formula sheet. You're gonna find the formula like this for your derivative table. This is a derivative table. When you differentiate sign, you're gonna get cos x. So you just use your formula sheet there. So remember what I said, take this, whatever it's there, then you say, let me write it nicely. So you take whatever that is here, your f of x, then you write it f of x. Okay, then in my case it's x. Okay, so you're just gonna say dy over dx equals to 1 over, you apply this formula right here. This formula, it's in your formula sheet. You apply this formula, it's 1 over They are saying it's 1 over x. What is our x in this case? It's sine x. Okay, multiply by d over dx. Then d over dx of what? Of sine x. Okay, so this d over dx of sine x, when you check in your formula sheet for derivatives, you're gonna find that when you differentiate sine, you're gonna get cos x. So when you differentiate this sign, you're gonna get cos x, a positive cos x. You just use your derivative table to get this one. So you're just gonna go back to the original formula and say dy over dx equals to 1 over sine x, okay, sine x, and then multiply by cos x. Remember sine over cos, it's what? Sine over cos, it's up to you if you want to simplify it further, but then remember, sine over cos, it's tan, and then cos over sine is the opposite of tan. So the opposite, the inverse, they normally call it inverse. The inverse of tan, it's a cot. The inverse of tan, it's a cot. So for this one, you're gonna get cot x. Cot x basically is the inverse of tan. So remember, normally when you get sine over cos, you're gonna get a tan, but then in this case it's reciprocal. So basically you took your cos up, and then your sine is your numerator, it's your denominator. I mean, your sine is your denominator, and then your cos is a numerator. So it's like cos over sine, not sine over cos. So the opposite of tan, it's cot, and then the opposite of sine, it's cosec, and then the opposite of cos, it's sec. So those are the opposite. It's they normally call it the inverse. So yeah, that's how you got this cot x. This is your answer. This is your final answer, or you can leave it in this form, cos over sine x. I don't think they can penalize you for that. Okay, so let me just write those inverses for you guys. Okay, so if you have got cos x over sine x equals to cot x, then if you have got sine x over cos x equals to tan x, so basically the inverse of this tan is cot. Okay, then you've got 1 over sine, this 1 over means the opposite. So 1 over sine, you're gonna get a cosec x. Then 1 over cos x, you're gonna get a sec x. This is your opposite. This is your opposite. This is how you solve them. So that's all for today. If you have got any question, just drop a question on the comment, or you could just text me via WhatsApp to ask the question. Otherwise, thank you guys for watching. Please subscribe and like the video. Thank you.